All right, so for proving identities here, this is number 18 on that handout that I gave you. Again, we're going to remember some of the simple rules, right? We want to use identities to transform parts of this proposed equation. So we're trying to prove whether this is an identity or not, right? So this equality sign is not really an equality sign where we can move things back and forth. We are not assuming equality, we're trying to prove equality. So we're going to make one of these sides look like the other side. So a good idea is to try and pick the most complicated side because you've got more to work with there. You've got more options to change. Which one's more complicated? Well, I'm not really sure. This one appears to be a little bit more to work with here. So why don't we talk about this one? Now we could start to explore different options here. And again, there's no right or wrong way to do this. But if you look at tan squared, is there any way you can change tan squared into anything? So again, look at your identities. So if we go back to our identities page here, I see tan squared right here. Okay? So tan squared actually is what? Because these are already proven, you can move things around here. So this tan squared could be secant squared minus 1, right? Secant squared minus 1. So why don't we do that? I'm going to do this, secant to the fourth theta minus 1 over secant squared theta minus 1. Okay? Is everyone okay with that first part there? Okay. So what you want to notice here is that, well, this appears to be a difference of squares, but so does this. Right? And because this is secant to the fourth, what you might see at this point is that if we factor this top, the numerator, as a difference of squares, we factor that, we're going to get this as one of the factors of top. So that's where you go with this. You say, okay, I want to be able to manipulate this, cancel out or divide out common factors. So that's a good place to go. So secant to the fourth is actually secant squared theta plus 1 times secant squared theta minus 1, right? If we factor that as a difference of squares. So down here now you have secant squared theta minus 1. And now you say, hey, I have a common factor, top and bottom. What am I left with? Well, I'm just left with secant squared theta plus 1. And that's actually what I wanted to show. And so there you go. QED, okay, you are finished. That is your proof. So this is clearly communicated, including this, the stroking out of the factors there. So please do all of that stuff to communicate to me that you know what you're doing and that you're using identities or whatever. I've circled tan squared here. This is obvious that I've just taken one thing at a time. I've moved tan squared to there. So if you can show that each step, you're good to go. Hey, any questions about that? This one I'm going to get you to try on your own, and what I want you to think about, and maybe give you some hints or whatever. More complicated side, probably left side here, I would say. All right, we definitely have a common factor in the numerator over here. Might be a good idea to factor that out. You're going to end up with a cos squared up there. You could do something with that. You could write this as as separate fractions, perhaps. You could also rewrite things in terms of sine and cos. That sort of thing. So go ahead and give number 21 a try, and then we'll walk through it in a minute after you've had a chance to try that. All right, so guys, this is by no means the only way to do this, but this is sort of the way that I did this. So I've already seen that someone has taken a little different route. This is what I did, okay? So I noticed that there was a cos in these first two terms. Like I'd mentioned, maybe I'm going to factor a cos out. So when I do that, I took a cos out of these first two terms only and brought me to this point right here. Now, cos squared minus 1 is the same as negative sine squared. If you go back to the identities, right, we have cos squared plus sine squared equals 1. That is sine squared equals 1 minus cos squared. If you took the sine squared to this side and brought the 1 over here, you would have negative sine squared equals cos squared minus 1. So cos squared minus 1 is negative sine squared. That's the first thing I did here, okay? So I turned this into this. Now, I wrote this also as two separate fractions here, two separate rationals. That's because I wanted to divide this out with this to leave myself with, excuse me, negative sine squared. This over here is easy to be shown as tan theta. So now I'm left with negative sine squared theta plus tan theta. And of course, if you just rearrange those two terms, you get tan theta minus sine squared theta, which is exactly what you're looking for, and you would be done. So a slightly different route, like the one I saw, was rewriting each of these as separate fractions right from the beginning, which is, maybe somebody else do that? I see head nodding. That's fine too. So I would encourage you for that first step, write this then, cos cube theta over cos theta minus cos theta over cos. I know it seems like it's a little unnecessary, but again, you're clearly communicating what you're doing. If you skip a step like this, you just may be in danger of kind of assuming too much in that process. So if you write this first, then that's good. This is cos squared, right, theta minus 1 plus tan theta. Then you can go and you can say, hey, this right here, negative sine squared theta, right? And then you switch those around and you're good to go. Okay? So those are very similar. There's little differences there on what I did first versus what a couple of you did first. That's totally fine.
Or can I just write that I would divide by cos theta to the bottom part and then the top parts? Can I write that?
All right. So number 27, okay, looks like this. Now, which is the more complicated side? Well, again, we have an indicated operation. So that's usually a good place to start, okay? Now, we have secant and tan, and we have cos, and all this sort of stuff. The other thing that you guys could do is you could rewrite each of these in terms of sine and cos right away if you want. So you have some options. You could either add these as they are, or you could rewrite things in terms of sine and cos and see how things shake out there. But I would start on the left side. So, having said that, let's do this in red. All right, so what we're going to do is we're going to need to multiply. Let's get a common denominator of tan theta cos theta. So that means I'm going to do secant theta times cos theta. And I'm going to have to add to that tan squared theta. Okay? Because, again, you're getting a common denominator, so you're multiplying this by what's on the other side there, and this by this one, right? So you're multiplying those two. Okay? Now, secant and cosine theta. What's secant times cosine theta?
1.
It is. Yeah, it's 1. So this is 1 plus tan squared theta. That's great because that's going to be part of an identity. Now, what about tan times cos? What is tan times cos? Well, tan is sine theta over cos theta, right? So if we multiply tan times cos, we actually get what?
Sine.
We actually just get sine. So in the denominator there, we have sine theta. And what's 1 plus tan squared as an identity?
Secant squared.
Yeah, it's secant squared theta. So you can kind of see that we're getting pretty close. Secant squared over sine theta, right? This is fine just to kind of go secant squared theta, and then the inverse of sine, 1 over sine, is what? Is cosecant theta, right? The one intermediate step that you could do there is this one, secant squared theta times 1 over sine theta, right? And that gives you a clear indication how you're going from there to there to there. But I think that's what we're looking for, right? Secant squared theta times cosecant theta. And so you are done. Okay, so perform indicated operations. If you're adding fractions or rationals, get a common denominator. You could have written both of these in terms of sine and cos, which I'll do. So what's secant? That's 1 over cos, right? Over sine over cos. This is sine over cos over cos. Okay? And you could simplify this right here, right, by flipping and multiplying. So 1 over cos times cos over sine. This one over here, again, flip and multiply. So sine over cos times 1 over cos. Right? So these, that's gone, that's 1 over sine theta. And this is sine over cos squared theta. Which, let me see here, what did I do here? Sine over cos, or cos. Okay, so that's the cosecant. So, yeah, I guess because these are added, so we have to add these up together. So that's going to be 1 over sine cos squared theta on the bottom there. So that's going to be cos squared theta. Over here, this is going to be sine squared theta over cos squared theta sine theta. So that's going to be 1 over sine theta cos squared theta, which is 1 over sine is cosecant theta times 1 over cos squared, which is secant squared theta. So that's another way to do that. That one takes a few more steps, but you could change everything into sine and cos, perform indicated operations, simplify, that sort of thing. So they would both get you this thing. One might be a little longer trip than the other. Okay.